All right, so today we're going to be looking at how both the Andes Mountains and Hawaii were formed. Now, we're going to get into what happens at all of these different types of plate boundaries and what other formations can happen with plate tectonics later on today. But I do want to give you and show you what I drew for my model. So for here, what we have is we have Chile, which is right on the coast of the ocean. Now, what we have here is you have two plates that are coming together. You have your oceanic crust, which is the bottom of the ocean floor, and you have the continental crust. And they're both moving towards each other. However, in this scenario, one of them is going to essentially win. And what happens is the oceanic gets pushed underneath. So that's why I shaded this part here red to sort of show you that it's being pushed underneath it. It's really, I know my artistic skills are not very good, but in this case, what's happening is they're still moving together. However, now what's really cool about this and why Chile and the Andes are so unique is because the continental crust has nowhere else to go. The continental crust can't go into the ocean and go push into the ocean floor. The ocean floor gets pushed underneath it, but the continental crust has nowhere to go. So what happens is it kind of like begins to like compress and like push together almost. It's almost I kind of think about it almost like an accordion. So what you do is this is still happening, right? So this has been going on for millions and millions of years. The oceanic crust gets pushed into the continent, and in this case, Chile, it's not going anywhere. And so what happens is that you get more and more crust that gets pushed under the continent, and the continent still has nowhere else to go. And the mountains that actually form there become larger and larger and larger. That's why that's why you can see in my model, the mountains start here as small, and then as they keep going on, they get larger and larger. And this is really what happens with mountains. Now, Chile's mountains are really, really unique in the fact um, that they almost could be volcanoes, but they're not. But in this case, all mountains are always formed by what we call convergent plate boundary. What that means is it just means that two plates are moving together. So all mountains are formed by convergent plate boundaries, meaning you have two massive tectonic plates. They get pushed together. And we're going to look at today a quick little video that shows how the Andes were formed. So take a look here. This is going to represent the oceanic plate, which is the one that goes underneath the continent of Chile. And it's going to be moving this way. And then you're going to have this plate here also moving this way. And you're going to see how the buildup of the mountains occurs in this area here.
Purge. As one plate subducts or dives beneath the other, the ocean basin closes. The continental crust, which is lighter than oceanic crust, cannot be subducted. Instead, as the continents collide,
so you can see the continent here has nowhere to go. So it kind of begins to compress and fold. And this is the buildup of how the Andes Mountains were formed.
The crust thickens and is forced up. Note how the sand is folded and faulted. We see similar structures in the rocks in mountains. One important factor not accounted.
So with all of this being said, you see these folds and this compression, almost like an accordion. I guess that's how I picture it. But this is happening over hundreds of millions of years. So the oceanic plate has nowhere to, it goes underneath, kind of has nowhere to go. So it begins to fold and create these giant mountains with folds and everything. So that's why Chile is so unique. Now, many of you probably have some background information or just have knowledge about Hawaii itself. Maybe you've actually been there. But it's true that Hawaii started off as underwater volcanoes. So at one point, all of Hawaii's land and rock started off on the bottom of the ocean floor. And that's a really weird idea to think about, but it makes Hawaii super unique. So here what happens, you have the ocean surface, right? But down on the bottom of the ocean floor, Those are the oceanic plates. And what happens is they actually move apart. So when plates move apart, it's different than when they come together. This is called divergent. So when the plates move apart, the mantle itself, this part of the mantle is actually made up of molten rock. So when the oceanic plates move apart, molten rock can come up in between that space, and that's all lava and magma, and then it cools to form rock. And so this happened again and again and again and again over millions and millions and millions of years. The oceanic plates kept moving apart, the mantle, and the magma kept coming up in between that space, and eventually it would harden and cool to form rock. So at one point, we could not see Hawaii. It was still just on the bottom of the ocean floor. But as time grew on, and enough of the mantle kept coming up in between that space, it would cool, and then was enough to poke over the surface of the water. So at one point, Hawaii was just barely over the ocean's surface level. But then you let millions and millions and millions and millions of years happen. You keep having this happen, and eventually you get these massive islands that now poke up above the ocean surface. So this took a really long time, but it's because the oceanic plates underneath move apart from one another, and they allow the mantle, the magma, to come up and cool to form rock. And then that was really the foundation of the land. Now, a bunch of plants and trees and people have eventually colonized and live on Hawaii, but the foundation of it started on the ocean floor. And it's because these oceanic plates, they moved apart. And the only we know what's underneath the crust is the mantle. And the mantle can be mostly solid, but it can also be liquid magma rock. And that's what we see here. And so that's how essentially we had Hawaii form. Even in volcanoes, the outside of the volcano that we see is rock, but on the inside, it's magma. And eventually, when there's too much magma or lava, it eventually breaks through or comes over the top or comes through the sides and cools to form brand new rock. And so some of Hawaii's islands are still growing in size. You look at these volcanic national parks, they still have eruptions, they still have new rock forming. The islands themselves are still slowly but surely shifting and changing. Now, some of the volcanoes are way more active than others. Some are just dormant, meaning they're not going to react. But it's all because of what started on the bottom of the ocean floor, which to me is pretty cool. So, thanks for watching.